Okay, I'm going to talk about this case study for Module 3, Simulation. Here's a problem, so I leave it to you to read the problem. I'm going to switch to a template, okay? So here's a template I built for you, and then here's the finished one. But I'm going to go over here to show you how to build the simulation. We will generate simulation by customer. Customer number 1, 2, 3, 4, so on and so forth. For each customer, we need to lay out the columns, the things we need to simulate. There's no standard formula or ways to do that. There's only one principle. You think along the process for a customer. What are the events experienced by the customer? And you think along that and generate the columns as you need. For example, let's take a look at this case. The most important thing in the simulation is to generate the columns. In this simulation, we're going to simulate over customers. Customer number 1, 2, 3, 4, 5, so on and so forth. How do we generate the columns? The rule of thumb is to think along the sequence of events. What happens next? So we think about customer number 1's experience. What is the first event when he comes to the store? Well, the first event is he arrives. So we need to know when will he arrive and what kind of information is available for that. Well, we have inter-arrival time. Inter-arrival time will help us determine the arrival time. Okay, so I know the first thing I need to generate is the inter-arrival time. With that, I can figure out the arrival time of this customer. Okay, what's next? When the customer arrives, well, we need to find out how many tires to replace. Okay, so that's the next thing. Okay, number of tires to replace. Once we know the number of tires to replace, what do we need to know next? We need to know when he will start the service. Okay, so let me have a service start time. And of course, at that point of time, I need to know how long does the service take. Okay, so I'm going to have a service time. Okay, so let me move it here. Service time. Once we know the amount of service time and the time the service starts, we can know when the service will finish. Okay, then we're good, and then we can calculate something that we care about. For example, in this case, how long does the customer wait and the total of time he stays in the shop. Okay, now let's start to generate simulation. Inter-arrival time. Well, this is something random. We know it's uniformly distributed with a mean of 10 minutes, max of 16 minutes. It's something we need to simulate, so that means we need a column to store the random numbers. So I have a column called rand. That's a random number, so it's just rand. And with that random number, I can generate simulation for inter-arrival time. And since the inter-arrival time is uniformly distributed, we know there's a formula. This is a formula for uniform distribution. If we want to simulate something called y that is uniformly distributed, this is a formula with mean, max, and rand. So I simply implement that formula here. Okay, it's mean. Okay, mean is this number, so I put $sign to fix the reference, plus max minus mean times rand, the random number, which is this number. Okay, I'm good. Okay, so this is the inter-arrival time. And what about arrival time? Well, for the first customer, because there's no previous customer, so the arrival time is simply the inter-arrival time. Then we need to find out the number of tires to replace. Now, to simulate the number of tires to replace, we actually know that the chance of having one tire replacement is 20%, the chance of having 2 tire replacement is 40%, so on and so forth. We can actually use Vlookup to do this. So I create a table. This is a table ready for VLOOKUP. This is exactly the same way it works for any other examples where we use VLOOKUP. Here it means that, well, 20% of time, one tire replacement, so any random number from 0 to 0.2 will represent having one tire replaced. Any random number from 0.2 to 0.6, that means 2 tires are replaced. Okay, so we're going to use VLOOKUP table here. That means we need to generate another random number. Okay, so I know I need to have another random number. Another rand. Tire replacement is now VLOOKUP. Look up the value. That's always a random number. Second, we need to give it the table. That's this VLOOKUP table. So I fix a reference. And then column index. So we wanted to return the second column in this table. So 2. And as before, it's an approximate match, so it's true. Okay, so here we go. So you can see now it works. Service start time. Well, for the first customer, because there's no one else in the store, so he will start the service immediately after he arrives. So service start time is simply the arrival time. The service time is slightly more complicated because it depends on the number of tires to replace, which is specified here. Because different number of tire replacement has a different distribution of service time. So I think it's useful to create 2 new columns just to record the mean and standard deviation of the service time. The service time is always normally distributed, but with different means and a standard deviation, depending on the number of tires to replace. So what I'm going to do is this. For the given number of tires to replace, I'm going to put the mean and the corresponding standard deviation here. And with those two numbers, I'm going to simulate the service time. So how do I do that? Well, you can use an if, a very complicated if. Well, for example, if this is equal to 1, the mean will be 20. Else, if this number is 2, then the mean is this, so on and so forth. If this number is 3, then it's this number, otherwise it's this number. Okay, that's one way. You can see 4 tires to replace, the mean is 42. You can do the same for standard deviations. So that's one way using an if function. I'm offering you another way using VLOOKUP. VLOOKUP. Okay, it's a different way of using VLOOKUP. Now we're looking up what? We're looking up the number of tires to replace. From what table? From here. This table. Okay, you see I select 3 columns. Fix the reference to the table. I want to return the mean, which is the second column. The key point is here. Instead of using true, I now select false. What does that mean? It means that VLOOKUP will try to find in the first column in this table the exact match, the number that is the same as this number. In this case, it's in column. It is in the first row. 1. This is 1, so it will return the second column here. That's 20. Likewise, I can do VLOOKUP. Again, look up the number of tires to replace from the same table, fixing the reference. But now I wanted to return standard deviation. That's the third column in this table. So 3. Again, false. Exact match. Okay. So for example here, one tire replacement means 20 standard deviation for 24. So we got what we need. Now we can simulate a service time from this distribution, the normal distribution with this mean and standard deviation. I need to simulate something, so I need a rand. Okay, I know I need a rand. Okay, rand. When it comes to simulating normal distribution, I know this is the formula I need to use. The function norm.inv. I want this random number as input with a mean of this, standard deviation of this. That's my simulated service time. Okay, it's a fractional number. And when do I finish my service? Well, it's always my service start time plus the amount of time it takes to complete the service. So this is my service finish time. What about the amount of time waiting? The amount of time waiting is always, well, the time you start the service minus the time you arrive. And the total time you spend in the shop is simply, well, the time you leave minus the time you arrive. So we just finished the simulation for customer number 1. Let's continue to customer number 2. Usually you have a different formula for customer number 1 compared to all the remaining customers, because there's something about customer number 1 that is different because it's the first one. So things are slightly different. Let's check out customer number 2. Rand number is still the rand. Inter-arrival time, is it still the same formula? Yes. Okay, so I'll copy this. I'm pasting here. Arrival time. The arrival time first customer is simply the inter-arrival time, but that is not the case for any future customers. Starting from customer number 2, it's the arrival time first, the previous customer plus the inter-arrival time. For tire replacement, do we need a different formula? Well, no, it's the same thing. Turns out to be the same thing. We don't need to change it, so I copy and paste. Service start time. Okay, this is slightly different. For the first customer, the service start time is simply the arrival time. But from the second customer onward, it's not going to be the arrival time. It may not. For example, in this case, the second customer arrived at this time, but the server will be busy with serving the previous customer until this time. So the service start time will be the time when the server becomes available. Generally speaking, it's the larger of, which means max, larger of the time the customer arrived and the time the service finished for the previous customer. That's a formula. Okay, and then we can figure out the mean, standard deviation, and rent and service time for customer number 2. This part of the calculation does not depend on anything about the previous customer. So I can simply copy the formula here. It only depends on number of tires to replace, so on and so forth. So I can copy the formula. Service finish time, again, it's the same as before. It's the same, so I copy it from the previous one with the 2 calculations. You can think about it. Turns out that they are the same as before. Okay, so basically we can copy a formula from customer number 1 as long as that thing does not depend on the previous customer. That's basically the rule of thumb. And then now we're ready. We can drag it down, or I'll simply double click this. We have the simulation. Okay, now we can calculate this. The average wait time for all of the 100 customers is simply now average out of the wait time from all of the customers entire column times shop, again average of total time shop. Okay, so these are simply statistics out of the simulation. Now we have a dynamic model that works. That's very great. But the problem also says that the owner of the shop try to figure out what happens if this number is not 10. Maybe it's 20 or 30. How would that change the average wait time over here? Specifically, it wants to do this. Let's try out 3 different values of mean, 10, 20, and 30. For each of them, let's run 20 simulation runs, and for each simulation run, let's store the corresponding average wait time. And then we're going to take the average of those 20 average wait time, and then we'll see what is the average wait time out of 20 simulation run when the mean is 10, 20, or 30. How do we do that? We need data table. Here's how you set up. So first, in this cell, we do equal to this cell. What that means is we're telling Excel, you know what? The number from this cell in the whole model is going to be the number you're going to report to fill in the table. Okay, that's the average wait time that we care about. Now select this area, data, what if analysis, data table. Row input cell means where do we want the first row here, 10, 30, 10, 20, 30. Where do we want Excel to put those numbers into the model? We will click on this cell because we want this number to be replaced by 10, 20, and 30 in the simulation. Column input cell, that means where do we want Excel to replace those numbers into. I'm going to click on any empty cell in this model. So what it will do later is this. Each cell here represent a simulation run. For example, what will be the number going into this cell? It will be the simulation with this number 1 go into this cell, and this number 10 go into this cell, the row input cell. And then you will run the simulation, return this number, average wait time, into this cell. Similarly, what will be the number in this cell? It will be the simulation with 2, the number 2, go into this cell, the column input cell, and 10 goes into this cell, the row input cell. And you run the simulation and then return the average wait time into here. Okay, so I mistakenly clicked this. Okay, so let me fix it. Okay, so now I hit on OK, and that's it. Alright, so we take average out of the 20 simulation runs, and that's it. We are done.